This video will give you an overview of data visualization. By the end of this video, you should understand what data visualizations are, why we create visualizations, how visualizations fit into the data science workflow, and some best practices for data visualization. Data visualization is a core component of data science. I'll frequently use the term visualizations. You might call them graphs. The intent of a visualization is to express information in a graphical or visual form. Visualizations are intended to, at a glance, summarize data, highlight relationships in complicated data sets, and communicate complicated analysis results. I'm sure you can all think of visualizations that you might have seen in the past. We'll just look at some here. Here we have a visualization that's intended to show you how many students choose a particular color as their favorite color. So as you can see, the height of each bar represents the number of students, and each bar corresponds to a particular color. And for a little added flavor, they've color-coded each bar to match the color that it represents. Here's a visualization from my own research. The blue line shows you the generation rate, or the amount of electricity that's generated from a unit of water falling through a hydroelectric dam. And the red line shows you the elevation of the dam's reservoir, so how high the lake is behind the dam. The core idea in this graph is to show you that strong correlation between the generation rate and the reservoir elevation. Here's a visualization that is a heat map of the density of fast food restaurants throughout the United States. Again, the core idea from this visualization is to show you places in the country where there are more fast food restaurants versus fewer fast food restaurants. Visualizations can be a lot more complicated. Here's a visualization that's looking at connections between the first 140 employees at Twitter. I challenge you to tell me what you should take away from this visualization. And here's another example of a complicated visualization that shows clusters of transportation between airports. So the lines represent routes that are flown by major airlines. The circles represent airports, with the size of the circle representing the relative size of the airport. Again, it's intended to show you how transportation networks are connected on the planet. So I've shown you all of these visualizations, and you might wonder, what exactly is the goal of visualization? The important thing with visualizations, you want to provide information that can be quickly digested simply by looking at the visualization. This means that with visualizations, simplicity is best. Looks cool is not the same as gets the point across. And I hope you saw that with some of those example visualizations, that while they looked really interesting, the core point or the idea behind the visualization was tough or even impossible to grasp just by looking at it. So what does this mean? Complicated styles, fancy options, or really cool graphics inside your visualization don't necessarily make it better. A good visualization is going to communicate its point clearly to the viewer. It's going to take very little time to process and understand the information in the visualization. And most importantly, good visualizations are self-contained. You have all the information you need to take the core point of the visualization away simply by looking at the visualization itself. You don't need someone to walk you through it or provide additional context in writing. I said visualizations are a core component of data science. Where are they going to show up in your workflow? You're going to use visualizations anytime you want to try and understand or communicate information. Visualizations can be used to understand, identify, and diagnose issues with your data. So during that data exploration and understanding phase, you'll actually generate visualizations on your own to help you understand the data that you have, map out relationships, look for anomalies in your data, and think about your strategy for modeling, generating forecasts, and generating decisions. You'll also use data visualization to explore relationships between variables. So you may have many variables in your data set. You'd like to understand how they're related to each other. Visualizations are an excellent way to do this. And lastly, this is something we think of the most with visualizations. You're going to use them to communicate analysis of results or features of your data to the end consumers of your analysis. But remember, you might be making visualizations the entire time you're working through your data science workflow, but only those final steps are you sharing with anybody else. I'd really like to take some time to focus on the best practices of creating visualizations. Most importantly, a visualization should communicate a single idea. Don't try and pack too much information or too many things into a single visualization. Focus on one idea and choose the information and the presentation that most clearly expresses that idea. Secondly, as I said before, visualization should be self-contained. Everything someone needs to understand a visualization should be included in the visualization itself. This means axis labels, a legend, a descriptive title, the units that are used in the visualization, and important notes that someone might need to understand the visualization should all be in the visualization itself. They shouldn't have to go looking somewhere else or ask someone for help understanding it. And lastly, you should keep your visualizations simple. There's a real tendency to show off your skills and to make complicated visualizations, but the fact is that the best visualizations only include features and data that are needed to communicate your idea. You want to avoid excess complexity in your visualizations, and definitely don't choose a visualization style because it looks cool. Choose it because it communicates your point effectively. Also, many of the default settings for visualizations in R and the R package that we'll use, ggplot2, were determined after consulting experts on visualizations. So messing around with the default settings, things like color palettes, point sizes, and so on, may at times be helpful, but in general are just going to be detrimental to people understanding your visualizations. Importantly, when you're creating visualizations, it's good to try things out. Making good visualizations is a skill that improves with experience, but importantly, you're trying to use visualizations to communicate. So when you create a visualization, a good way to see if it's effective is to show it to someone who doesn't know the point that you want to communicate and see if they understand what you're trying to get across with the visualization. If it's immediately obvious to them, you've done a great job. If it takes a lot of explaining, you might want to rethink your approach to visualizing that information. So again, these are the overarching concepts you should have in mind when you're creating visualizations. Next, we're going to move on to actually creating these in R.